Okay, so in question 5, I'm going to ask you to pause the video and read through the question again. Just remind yourself of what the question was asking you. So in part A, we're asked to identify the first two errors that Julie has made. So the first error is here in her alternative hypothesis. It should not be greater than or equal to, it should be greater than 0.15. Our null hypothesis is that P is equal to 0.15. The alternative hypothesis should be either not equal to or greater than or less than. The second mistake that she's made is in her calculation with the test statistic. She's looked at probability x equals 8. We should be checking the total probability of x being greater than or equal to 8. Just a point, just a reminder, we're always looking for testing the probability of the value or more extreme cases. So in part B, it says explain whether the errors will affect the conclusion. We can't tell immediately from here. If this probability that it was equal to 8 was greater than 5%, then she wouldn't have rejected the null hypothesis. And if that had been the case, then the probability that x is greater than or equal to 8 would also have been greater than 5%, and we would have had the same conclusion. But here, just because that probability is equal to 4%, it's less than 5%, doesn't mean that when I look at x being greater than or equal to 8, that would still be the case. I don't know, so we're going to have to work it out. I'm going to have to look at, for this distribution, x belongs to binomial 30, 0.15. What is the probability that x is greater than or equal to 8? Well, it's 1 minus the probability that it's less than or equal to 7. Calculator or tables, and we get that, and there's our answer. So this time, the probability it's greater than or equal to 8 is actually 0.0698, larger than 5%, so she would not reject H0. Okay. So then just checking, have we answered the question? Will the errors affect the conclusion? Yes, they do affect her conclusion. There's quite a lot there for 1 mark, but that is needed. Okay, for part C, we now want to find the critical region to test the shopkeeper's belief. So just a recap of what we've got. Our null hypothesis, alternative, and the distribution that x belongs to. We're looking at a one-tailed test at 5%. We want our critical region such that the probability that x is greater than or equal to that critical value is less than 5%. I'm going to translate this now into less than or equals to. So it's 1 minus, and it's less than or equal to C1 minus 1. If I rearrange that, I'm looking for now the first value that is greater than 95%. At this point, it's easiest to go to the tables. So here's our relevant table in the back of the book. We've got n is 30 and 0.15. We're in this column here. And we can see just down here the values where it's below 95% and it just goes above 95%. Now, to ensure you get full marks on your papers, I would write both of those down. So less than or equal to 7 is that. Less than or equal to 8 is that, and we're showing that that's the first one then, where it is greater than 95%. So here we can say that C1 minus 1 must equal 8, C1 equals 9. How I answered the question, it asks me for the critical region, So just putting C1 equals 9 isn't really good enough. The critical region is for values between 9 and 30. Part D, we've done the hard work. The actual significance level then is 1 minus the probability of it being in that region. And there's the actual probability of that, so 0.0278 or 2.78%.